Good day everyone. So I am Sir Confidence from High Achievers Academy. So today we are going to be discussing about the mean value theorem. So the mean value theorem is a fundamental topic for every engineering student, every computer science student, mathematical students. The mean value theorem is a topic under calculus 1. So if you fall in that category, this video is for you. Now, without wasting much time, let's dive deep down into this. Alright, so for our objectives today, we're going to understand the concept of and the conditions of MVT. We're going to learn how to apply MVT to solve problems. We're also going to talk about the Rolle's theorem and we'll solve past questions. Now, let's dive down into understand the concept of the mean value theorem. So this is the statement of the mean value theorem, and it is needed for you to actually know this, because if you are to solve any problem related to the mean value theorem for theoretical exam purpose, you always need to have the statement of head, because I believe your marking guide should come first with the mean value theorem formal statement. So it states that provided that a function f of x is said to be continuous on the closed interval a comma b, and is said to be differentiable on the open interval a comma b, then there exists at least, that is a key point to note, at least one point c in a comma b such that f prime of c is equals to f of b minus f of a all over b minus a. We'll come back in breaking down the statement further. We'll come back to break down the statement further. So the formal statement is needed for you to actually know this very, very well. So we have closed interval, we have open interval. We've talked about continuity and differentiability. I believe from the experience of the limit of a function, you should have some understanding about continuity and differentiability. But we're not going to dive into that today. We're not going to be doing that today. So proceeding, let us check the condition of the mean value theorem. So there are two conditions for the mean value theorem. The first condition is that the function must exist. The first condition, the function f of x, must said to be continuous on the closed interval a comma b. Then the second condition is that the function must be said to be differentiable on the open interval. Then there should exist at least one point in the open interval of a comma b. Alright, so these are the two conditions of mean value theorem. The first condition is continuity on the closed interval. The second condition is differentiability on the open interval. I'm going to explain more on this and break this down. So let us check out what we mean by continuity and differentiability. We're not going to dive deep down into that. I'm just going to stay at the surface. So when we're talking about continuity, a function f of x is continuous as x is equals to a if f of x is defined, at that point, that is at the point of a could be anything, it could be negative integer, it could be a positive real number. So as at that point a, if the function f of x is said to be defined, if it's having a defined value, that's a value which can exist on our real line, not a complex number, then we consider that function is said to be what? Continuous. We're going to illustrate that. Then we also have the limit. When the limit exists, as left hand limit is equal to the right hand limit. Now for differentiability, we have that a function f of x is said to be differentiable as x is equals to a if one, it is continuous at x is equals to a. This simply means that for a function to be continuous, for a function to be differentiable, that function has to be continuous. So for a function to be differentiable, the first thing that comes first is what? Is continuity. Alright, so we also have that the left and right derivatives exist and are equal. So we're going to be illustrating that. So let's illustrate that so you have more proper understanding on what we are talking about today. So we've talked about continuity, we've talked about differentiability. So let's see if we can do some little illustrations on that. So when talking about the continuity of a function, if I have a function, we'll do something very simple. If I have a function f of x, and f of x is equal to 2x plus 5, and this function exists at an interval of 1, let's say 1, 2. Now, how can we check if this function f of x is continuous at this point? Let's call this point A, and let's call this point B. So to test that, we're going to find f of A, and we are going to see if f of A is said to be defined. So A is 1, so this is going to be 2, and wherever we see x, we replace it with 1 plus 5, and this is giving us 7. So 7 is a number which is defined on our real line. So therefore, we can say that f of A exists. F of A exists. So we can also try for f of B, and it's also going to exist. So there is one thing which you need to know, is that all polynomial functions will be said to be defined as continuous at any interval. So if we have, for example, if this was 100, if I decide to put 100 inside here, I'll still have a number which is defined. If this was negative 2000, if I put it inside here, I'll still have either a negative or positive number. So that is that for continuity. So let us look at some conditions when a function can said to be discontinuous. For example, if I have a rational function such as f of x is equal to, let's say, x squared divided by x squared minus 4 at interval 1, 2. At interval 1, 2. Let's use this instance. So f of A, if we were to check for f of A, we are simply going to replace, this is A and this is B, so we are going to replace 1. So this is going to be 1 square over 1 square minus 4, and this is going to give us 1 over negative 3, which is negative 1/3. Then we can check for f of B, and f of B is 2, so this is going to be 2 square over 2 square minus 4, and this is going to give us 4 over 2 square is 4, 4 minus 4 will give us 0, and this will be undefined. So therefore this function will be said to be discontinuous. There's going to be a jump. When we talked about continuity and differentiability, we talked about jump in loops. I'm not going to go into that today. So this is that. So let's look at a rational function. For example, if we have a rational function now, let's say I have okay, we've talked about the rational function. Let's look at a square root function. If I have f of x is equal to the square root of, let's say, x minus 3 at interval 1, 5. If I put test for f of A will be equal to the square root of 1 minus 3, and that's going to give me the square root of negative 2, which is 2i, and this is a complex number, not a real number. So this will be said to be what? Undefined. If I put in 5, f of b is going to actually be defined, but f of a won't be what? It won't be defined. So this function will not satisfy mean value theorem. So when talking about differentiability, so let's discuss a bit about differentiability. We've talked about continuity, and you've seen how a function can said to be continuous. So let's talk about differentiability. If I have f of x, let's use a polynomial function. F of x is equals to 2x squared minus 3. Let's use something very simple. At, let's say, open interval, because differentiability in mean value theorem rule, the condition talked about this being in an open interval. So there's a difference between open interval and closed interval. For example, if I have open interval of 1, 4, At this interval, 1 is also included at this interval, as well as 4. 4 will also be included. But in this interval, for an open interval, and 1 and 4 won't be included in this interval. What will be included is 2. We're going to have 2. We're going to have 3. So these are the two numbers that will be able to exist at this open interval. That's the difference between the closed interval and the open interval. So we're not going to be doing number line in this class, so I'm not going to go further into this. Alright, so proceeding, let's discuss about differentiability. That's what we wanted to do. So if I'm to test if this function is differentiable, I'm to find the first derivative of this function. So I'm going to say f prime of x, and f prime of x will be equal to the general rule of differentiation. You drop down the power, multiply by the whole expression, and subtract 1. So this is going to be 4x. If I put in 1 inside here, that is f of a is going to exist. It is going to give me 4. And f of b, which is putting in 3 into x, would give me 12. And this f of a and f of b will said to exist. So therefore this function we said to be differentiable at this interval. So all polynomial functions will always be continuous and differentiable. So it's something which you have to know for exam purpose. So from the square root function, always watch out for negative arguments. For the square root function, always watch out for negative arguments. Then for the polynomial function, like I've said before, is continuous across all interval. For rational function, you have to watch out for the denominators. So denominators are very, very important. So we've talked about continuity and differentiability. Now let's look into the mean value theorem. So we said that let's have a quadratic equation. Let's have a function for a quadratic equation. Let's have something looking like this. So we have the slope of the tangent line, and we also have the slope of the secant line. So we have the slope of the tangent line, and we also have the slope of the secant line. Now we said that f in this equation, we're going to have for this function, let's call this to be a function of f of x, where we have the slope of the tangent line and we also have the slope of the secant line. So we're going to have that for this function, if this function is satisfying mean value theorem, this function must be said to be continuous and differentiable. So we're going to now have that f prime of c, which is the general formula for the mean value theorem, f prime of c will be equal to f of b minus f of a over b minus a over b minus a. So this is known to be the tangent. This is known to be the slope of the tangent. This is known to be the slope of the tangent line. This is known to be the slope of the tangent line. And why this is known to be the slope of the secant line. This is the slope of the tangent. This is the slope of tangent, slope of secant. So the slope of the tangent is also known as the instantaneous rate of change. The slope of the tangent is also known as the instantaneous rate of change. Why the slope of the secant is known to be the average rate of change. Those are some key points which you need to take down. I said the slope of the tangent line is said to be the instantaneous rate of change, while the slope of the secant line is said to be the average rate of change. It's said to be the average rate of change. So proceeding, we are going to implement this formula in solving some problems. We are going to implement this formula in solving some problems. Alright, so I have some questions here. So we're going to implement and solve some problems. So question 1. So from here we have question 1. So question 1 states that find all possible value of c provided that the function f of x is equals to x squared minus 4x plus 1 at closed interval 1, 5 satisfies the mean value theorem. So let us solve. So we have our function x squared, x squared plus 2x. So we have our function f of x, x squared minus 4x plus 1. So we have our function f of x is equal to x squared minus 4x plus 1 at interval. So the intervals are interval of 1, 5. Interval of 1, 5. So the first thing which you need to do in solving for a theoretical course, you need the statement of the mean value theorem. But I'll proceed since we started using the statement. So I'm going to leave that. I'll proceed without the statement. So this is the statement here. In case you missed where we started from, this is the statement of the mean value theorem. So I'll start with the formula that says that f prime of c is equal to f of b minus f of a over b minus a So let us find f prime of c. But before finding f prime of c, we need to find f of c. So finding f of c, if f of x is equals to x squared minus 4x plus 1, what will be f of c? F of c would be c squared. Wherever we see x, we replace it with c. C squared minus 4c plus 1. C squared minus 4c plus 1. That's going to be f of c. Then the next thing to do is to find the first derivative of f of c, which is f prime of c. So we're going to have that f prime of c will be equal to 2c minus 4. That is the first derivative of f of c. Then we're going to proceed for finding f of b and f of a. So we're going to have that f of b will be equal to, this is going to be is a is 1 and b is 5. So f of b, we're going to, wherever we see x, we're going to replace it with what? With 5. So f of b will be equal to 5 squared minus 4 into 5 plus 1, and this is going to give us 25 minus 20 plus 1, and this is going to give us 6. So f of a would be equal to, wherever we see x, we put in 1, and that is going to be 1 squared minus 4 into 1. 1 squared minus 4 into 1 plus 1, and this is going to give us negative 2. Now, applying this into the mean value theorem formula, we're going to have that, applying to this formula, we're going to have that f prime of c. So let's apply using the mean value theorem formula. This is going to be 2c minus 4, that is f prime of c. And we say this should be equal to the average rate of change, and this f of b is 6. What is f of a? F of a is 2, and b minus a, this is b, this is a, 5 is b, 1 is a, and this is going to be 5 minus 1. So at the end of the day, we're going to have that 2c minus 4 is equal to 8 over 4. And well, therefore, we're going to say this is going to be 2c minus 4 is equal to 2c minus 4 is equal to 2. Then we're going to have that 2c is equal to 6. And we divide all sides by 2. We divide all sides by 2, and we say that c is going to be equal to 3. and therefore the points that exist, at least that one point which exists in this interval, is equal to what? Is equal to 3. All right, so let's take the next problem. Let's take the next problem. So the next problem, that's question 2. Next problem said find all possible values of c provided that the function x cubed minus 3x squared plus 2 at interval -2, 2 satisfies the mean value theorem. So let us proceed. Let us proceed and solve question number 2. So I'm going to clean this up. So let's dive deep down into question number 2. So you can try it out yourself before we solve together. This is the question. You can try it out yourself before we solve together. So you can pause the video and try it out. So for question number 2, we're asked to find all possible values of c provided the function f of x. We have our function f of x is equal to x cubed minus 3x plus 2 at the interval of -2, 2. All right, so I'm solving. We're going to have that f prime of c, the formula will come again, is equal to f of b minus f of a over b minus a. And what is f prime of c? Before we find f prime of c, we have to find f of c. So f of c would be equal to c cubed minus 3c plus 2. Now, so f prime of c would be equal to, that's the first derivative of f of c, and this is going to be 3c squared minus 3. This is going to be 3c squared minus 3. Then we have to find f of b. So what is a, what is b? This is a and this is b. So a is minus 2, b is 2. So to find f of b, we put in 2 wherever we see x in our equation. So this is going to be 2 cubed minus 3 into 2 plus 2. And we're going to have that f of b will be equal to 4. Then for f of a will be equal to, we'll put in -2. So this is going to be -2 cubed minus 3 into -2 plus 2. And this is going to give us 0. -2 into 3 is 8. -3 times 2. This is going to be +6. +6 plus 2 is 8. 8 minus 8 is 0. So now let's implement the formula. Let's implement. So implementing, we're going to have that from our equation here, from my equation up here, as a general formula for the mean value theorem, we're going to have that f prime of c is 3c squared minus 3. And this should be equal to the average rate of change. F of b is 4, f of a is 0, and we're going to have that b minus a is 4. So therefore, we're going to have that 3c. Therefore, we're going to have that 3c will be equal to, okay, let's take this step by step. Let's not read the process. So we're going to have that 3c minus 3 is going to be equal to 1. 4 divided by 4, that is going to be 1. So we're going to have that 3c squared is going to be equal to 3 plus 1, because we can move 3 to the other side, or we can add 3 in both sides. So therefore, we're all going to have that 3c squared 3c squared is equal to 4. Then we divide all sides by 3. We divide all sides by 3. And we're going to have that c squared is equal to 4 over 3. Then therefore we can say that c is equal to, can square all sides and have that c is equal to the square root of 4 over 3. We can have that c is equal to 1.15. So the value c which exists at the function on the interval of negative comma 2 closed interval is equal to 1.15. So let's take the third example. Let's take the third example. So the third example says that we should find all possible value of c provided the function f of x is equal to the square root of x minus 4 at the interval of 1, 5 satisfies the mean value theorem. So this is a square root function. So from the problem has said that the function satisfies the mean value theorem. So we don't need to actually test for continuity and differentiability. We can actually solve directly, since from the question already it is said that this function satisfies the mean value theorem. So that's going to save us more stress. So we have that function to be the square root of x minus 4. We have that function to be the square root of x minus 4 at the interval of 1, 5. Okay, this is from a past question. I think there should have been a mistake in the interval. So the interval is the interval of 4, 8. That's the interval. I think I made a mistake here. So this is directly from a past question. So I will drop the past question below, so you can actually look at the past question. So we have that the function f of x is equal to the square root of x minus 4. The square root of x minus 4. Now, at interval, from the past question here, the interval is 4, 8. The interval is 4, 8. And it is said that this function satisfies the mean value theorem. So we don't need to test for continuity and differentiability. So the first thing to do is to have the formula of the general equation of the mean value theorem, where we have f of c is equals to f of b. F prime of c is equals to f of b minus f of a over b minus a over b minus a. And what is f of c? F of c is going to be the square root of c minus 4. We replaced x for c. Then to find f prime of c, we need to find the first derivative of this function. So first of all, we're going to be using chain rule, but I'm going to be teaching you a shortcut in doing this. So the first step is to write this from historical form in this form. So this is going to be c minus 4 to the power of 1 over 2 to the power of half. So with my shortcut, the first step is always to drop down the power, which is half. Then the next step is to differentiate the arguments, that is what is in the bracket. If we differentiate this, we're going to have 1, and the next thing is to rewrite the equation but subtract 1 from the power. So we're rewriting this, subtracting 1 from half, and we're going to have negative half. So at the end of the day, this is going to be equal to 1 over 2 root c minus 4. 1 over 2 root c minus 4. Now we have to find f of b. So what is going to be f of b? So f of b will be equal to the square root of 8 minus 4 and this is going to give us the square root of 4, which is equal to 2. Then we'll proceed to find f of a, and f of a is going to give us the square root of 4 minus 4, which is the square root of 0, and the square root of 0 will give you 0. So after doing this, we are going to proceed now to implement. We have f prime of c, we have f of b, and we have f of a. So we have everything which we need in our general formula. So we can therefore implement. So we can implement. Let's clear this out. So implementing our formula, we're going to have that f prime of c. What is f prime of c? That is 1 over 2 root c minus 4, and we see this is equal to the average rate of change, which is f of b minus f of a all over b minus a. And what is f of a? F of a is 2. What is f of b? Sorry, f of b is 2, f of a is 0. What is b? B is 8, while a is 4. So this is going to be 8 minus 4, and we know that 8 minus 4 is going to give us 4. So we can erase this, go straight to the point, and have this to be 4. So we can cross multiply. And we are going to have that 4 is equal to 4. 2 is going to multiply 2. So when you cross multiply, 4 will multiply 1, 2 will multiply 2. So 4 root c minus 4. Then we can divide all sides by 4 to have that 1 is equal to the square root of c minus 4. Now we can square all sides. To have that 1 is equal to, you can square all sides to have that 1 is equal to c minus 4, and therefore we can add 4 in all sides to have that c is equal to what? Positive 5. So this is the value c that exists. Now there's a pattern which we've been following all the while. If you notice, our values of c is always between this interval. So that's something which you need to take note for exam purpose. Your values of c would be between the intervals of a and what? And b, provided that this function satisfies the mean value theorem. So we've worked with mostly polynomial function. We've worked with the square root function. So in our next video, we are going to look deeply into other functions, such as the exponential function. We can look into the trigonometry function. So bye for now. Enjoy.